Hi folks, we're going to take a look at page 433, number 14. So here they've got a fire station which serves an area bordered by these three highways. Okay, so forming that triangle. And it tells us that the fire station serves a total area of 126 kilometers squared. And it wants to know the number of minutes it would take for the fire truck to drive the perimeter of the region. So essentially, we're looking for the perimeter of this triangle. Okay, and they give us a speed of 80 kilometers per hour. All right, so since they're looking for number of minutes, so that's time, they give us the speed, meaning that we're going to have to find the distance, again, like we said, the perimeter of this triangle. So let's see what we have. So we already have one side of this triangle, so the goal is to find the other two sides. Now, very interesting that they give us the area, all right, and they've also given us essentially the height of this triangle. All right, so let's think about how we could use that. Remember, area is just 1/2 base times height. So without using any trigonometry, we could actually use the area formula to find the base of this triangle. So that'll be quicker. So let's do that. So if we call this, let's call this x here, this side length going all the way. And so we have that the area is 1/2 base times height. All right, so the area is given as 126, 1/2 times the base we called x, and the height of this triangle is given as 12. All right, so we have x is equal to 126, and here 1/2 of 12 is 6, so we're just going to divide by 6. And so let's see what that is. Probably do this in our heads, because 6 goes into 12 two times, and then we're left with the 6, which goes into 6 one time, and there we go. So we have 21 kilometers. So now we have two of the three sides. All right, so let's see if we can use some trigonometry now to find this fourth side. So let's see what I know. I know this side and its opposite angle. So I know that I have to use sine law, but I know this side length, and the only thing I can determine is its opposite angle. All right, we can't directly calculate this opposite side. Okay, so step number one is to calculate this angle theta, and then from there we'll be able to, I believe, calculate that side length. All right, so we have to do it in 2 steps. All right, so let's set this up. I'm looking for theta, so I'm going to put the sine expressions in the numerator. Sine of theta over its opposite side, which is 17, equals, and on the other side, we'll take the known ratio. So we've got sine of 82 over its opposite side, which is just this x, which we just determined, 21. Okay, so theta is going to be equal to, well, let's think about what we'd have to do. First, we have to multiply the 17 to the other side. So 17 sine 82 over 21. And then to isolate for theta, I have to take inverse sine. All right, so this is what I'm calculating. So let's put all this, see how we can do it in one step in our trusty calculator. So let's see what we have. We have inverse sine of 17 times sine 82. Whoop, 82, not 81. Okay, and divided by 21. And that gives us 53.29. 53.29 degrees. Okay, and so now that we know this angle, well, we can use, sine law to calculate this side here, because I have a side length and a known angle, side length and a known angle. And here I can just easily find the third angle opposite to the side I'm looking for. So let's call this y, by the way. Okay, but something I think even easier is, hey, look, this y is part of a right angle triangle, and I know the opposite to theta, and I know theta itself. So I think I'm going to use a primary trig ratio. Okay, a little easier than working with the full triangle. So since I know opposite and I'm looking for hypotenuse, I'm going to use sine. So we have sine of theta, which we just found was 53.29, is equal to opposite, which is 12, divided by hypotenuse, which is what we're looking for. Okay, so since the variable's in the denominator, I'm going to have to do some cross multiplying. I'm going to multiply the y to the left and divide the sine 53.29 to the right. So y is equal to 12 over sine of 53.29. So that's equal to, okay, so 12 divided by sine of 53.29. Okay, so actually we'll make that exactly 15, because even if I go to 2 decimal places, 14.97, we'll just make it 15, since the other two sides are given as integers. All right, so there we go. So now we can find the total distance that's traveled. All right, so the distance is going to be equal to the perimeter of the triangle, which is 17 plus 21 plus 15. Okay, so let's see what that's equal to. So 17, 27, 37, 38, 48 plus 5 is 53. So that's 53 kilometers. All right, and so now if we're looking for the time, remember velocity or speed is equal to distance over time. So if I want to find time, I just have to do a little cross multiplying here. Multiply t to the left and divide v on the right. So the time is a distance of 53 kilometers divided by a speed of 80 kilometers per hour. And we're left with, let's do that here, 53 divided by 80 is 0.6625 hours. Okay, but they don't want the answer in hours. They specify that it has to be in minutes. Okay, so we're going to change the units. So 1 hour is the same as 60 minutes. So this is just going to be 0.6625 times 60 minutes. All right, and let's see what that gives us. And we already have that in our calculator, so times 60, so that is 39.75 minutes. All right, so let's recap here, because this again was a question that had quite a few steps involved, but the idea was to have a plan. So step number 1 was to see how we could use the area to easily find the second of the 3 side lengths. Okay, so we just use the area formula to determine that this side length was 21. Then we realized that we could use sine law on the whole triangle, but first we had to determine this opposite angle to 17, all right, which we did here, and then we could use that angle and this known side length in this right angle triangle to determine the final side of the big triangle, which was 15. From there, we found the perimeter, and then we used our formula for velocity, distance, and time to determine how long it would take. But the answer we got was in hours. We just had to multiply by 60 to determine how many minutes. All right, that's it for this one.